G'day guys, I've been presented with this particular calculus of exponential equations question. I feel like it's from a local test, and I find this a relatively interesting question for a number of reasons. But the main one is because on the surface, this particular presentation of the calculus of exponential equations looks like it's going to be very, very difficult. And a lot of kids would look at it and go, oh, there's no way I could solve this particular problem. However, once you just dig down a little bit, once you start nutting out the first parts of this particular question, a lot of the time students are relatively surprised with how simple the eventual question becomes. So what I'm going to do is I'm going to solve this question in two ways. First, I'm going to solve it by hand without a calculator. And then what I'm going to do, because I think this particular question is coming from a calculator section where you can use a ClassPad style device or a graphing calculator like you see on your right. So I'm then going to show you how I would use this particular piece of technology to help me under test conditions. Okay, so let's get to it. We've been asked to determine the values of k for which this particular exponential equation is a solution of this equation here. So what I'm going to do, guys, is I've got my first one, y is equal to e to the kx. Now, what I'm going to start by doing is finding the derivative of this so I can have this particular part of my equation. So I'm just going to write that down at the top here. So we have dy dx is equal to, now we just bring the k down, it's like a chain rule, k e to the kx. Now, if you're watching this video, guys, I'm going to be assuming that you understand the basic principles of differentiation of these exponential equations. So I'm then going to find the second derivative. So I'm going to take the derivative of this one. So I have my d squared y over dx squared. And that's going to be equal to k squared e to the kx. Great. Now what I'm going to then do, guys, is I'm going to get these three equations and I'm going to substitute them into this particular formula. What I end up with is 2 times the second derivative, k squared e to the kx, minus the first derivative, k e to the kx, minus 3 times the initial equation, 3e to the kx. Now this is all equal to 0. Now what you guys may notice from here is that we have a common factor of e to the kx, and I'm starting to see red flags that I might have to apply a null factor law. So the first thing we're going to do, guys, is I'm going to factorize by that common factor of e to the kx, and we're left with 2k squared minus k minus 3 is equal to 0. Now we can see that there's a quadratic beginning to form here. Now, if we're not using a calculator, from here what we're going to have to do is factorize this quadratic. Now, we have a non-monic quadratic equation here, so I'm going to split the middle and then factorize it. So I'm going to take you through all of my steps, guys. So I'm still left with e to the kx. I'm going to go, well, 2 times negative 3 is negative 6, and then so it's going to be negative 3 positive 2. Okay, so go 2k squared minus 3k plus 2k minus 3 is equal to 0. Now, these two are equivalent quadratic equations. That k has just been split into these two values. I then can factorize the front two by just k, and I have 2k minus 3, and I'm going to factorize the back 2 by just 1 and have 2k minus 3. Hopefully you can see here, guys, that it's e to the kx is now going to be equal, well, e to the kx multiplied by 2k minus 3 multiplied by k plus 1 equals 0 up here. So I'm going to apply the null factor law up here, guys. What you're going to see is that e to the kx is going to have to be equal to 0, or 2k minus 3 is going to have to be equal to 0, or k plus 1 has to equal 0. Now, for the e to the kx equals 0, there is no solution for this. There is no value of k which e to the kx will equal 0. So for this one here, we can do a little bit of algebra and say that k is equal to 3/2 or 1.5. And we can also do a little bit of algebra here and say that k is equal to -1. So we have no solution for the e to the kx part, but then we have two solutions for that final part. So the values, plural, of k is we can say that, well, k is equal to 3/2 and k is equal to -1. Now, I'll just remind everybody that it's important that you know how to do it without the calculator, because you want to be able to have an idea of the methods that the calculator is using for you to be able to get to the right answer, because you don't want to get to an answer and not be able to assess whether it is in the ballpark of what you're looking for. Okay, so with the calculator, guys, what I'm going to do is I'm still going to write down my three different derivatives. I have y equals e to the kx. So my next one, guys, what I'm going to do is I'm going to go into my calculator. If we want to make sure we're not making any mistakes, is when we go into the calculator, guys, we go into our Math 2 section of our keyboard and do the derivative with respect to x. Now this is an exponential. Now I substitute k for something like y, or we could put z if we wanted to. So we have a derivative with respect to x of e to the zx. I hit enter, and I just have to remember to make sure I substitute k back in for z. So we can see here, guys, this is dy dx is going to be equal to k e to the kx. Now what we can do is we can either take the derivative of that, or we can take some arbitrary derivative, and this one here is going to be our second derivative with respect to x of e to the zx. And you can see here, guys, d squared y over dx squared is going to be equal to k squared e to the kx. So we're going to substitute them into the equation. We have 2k squared e to the kx minus k e to the kx minus 3e to the kx equals 0. Now from here, guys, where this gets a little bit interesting is in the calculator, I can go, well, it's 2, and then I put that value down, and then we have minus the first derivative minus 3 times the regular function. So we have e to the zx. Now from there, that has to equal 0. Now what we can then do is we can simply go interactive, transformation, factor, and it gives us the fully factorized form. We have to make sure that we continue to substitute k for z in the calculator, and we can straight underneath write k plus 1, 2k take 3, e to the kx equals 0. You won't need your calculator for the last piece, because you'll be able to go, well, there's no solution. K here is going to be equal to 3/2, and k here is equal to -1. So that's the video, guys. It was a relatively quick question. Obviously, it's a lot easier to solve when you just use the calculator to do all the heavy lifting for you. I feel like it's important to be able to do this particular method here, understanding how you do algebra involved in the quadratic to ensure that you can simplify those every single time under test conditions. But when you're given a calculator in an exam, guys, it's always the best idea to use it. So I hope that video helped, guys. If it did, give it a thumbs up. Subscribe to my channel. I put out new videos as often as I can. I'm going to start doing more of them. If you'd like to see a particular question on a particular topic, just drop a comment in the comment section below, and I'd be happy to take on a new challenge. So thanks for watching, guys, and I'll see you here again soon.